Unfortunately, Leora was unable to join us this evening, so Ira will be playing her introduction video that she recorded ahead of time.
Good evening, everyone. My name is Leora Spitz. I graduated SK in 2016, and I have the pleasure of introducing you all to Talya L, who is currently in 11th grade at SK. Over the past few months, I have had the absolute privilege of learning just how bright, motivated, and impressively organized Talya is, even when perhaps I was not. Throughout our time together, Talya was able to learn how to read scientific literature, how to analyze data, especially using a new computer software that she taught herself how to use, how to interpret results even when they didn't come out as expected, which is an important scientific skill that she really excelled in. Talya also completed a laboratory component in addition to our data analysis. She crafted her own procedure and she built all her own materials. I loved how excited she was to be able to see our work in action and gain a deeper understanding of the data that she was analyzing. I have no doubt that Talya is going to succeed in whatever career she chooses, whether that be STEM or not, though of course I am biased. And now I hope that you all enjoy hearing about Talya's work.
So, hi, my name is Talya L. I'm in 11th grade, and I obviously go to SK. Next. So, my mentor, her name is Leora Spitz. She currently works in a Barnard chemistry department in the lab. It's called the Viscara lab. She studies biochemistry, specifically focusing on formins and inhibitors, which is related to what my project involves. And she is originally from the Lawrence, that town, but she currently lives in New York City. And some of her hobbies include attending a theater, cooking, and reading. I share the reading part. Next. So my project, I named it Finding the Fluorescence. Really stemmed from I learned in AP biology things related to microtubules, and that's some of the work that my mentor focuses on or is related to. And so that's kind of where it came together. And so after we decided on that, I started by researching several related terms to what my project would be, such as formins, microtubules, inhibitors, and fluorescence intensity. So fluorescence, which is finding the fluorescence, essentially means emitting light. And really one main reason why I selected this project was to learn research skills and lab skills because it's useful for any field, even beyond science. Next. So my demo or just my project really started by learning this program called Fiji, which is just a program that analyzes images for fluorescence intensity. So, and also in addition to that, the microtubule binding with different concentrations of inhibitors. So the inhibitor, either it means it inhibits or it stops microtubule binding, or with no inhibitor, it wouldn't stop the microtubule binding. And so I learned a lot of topics and technologies like analyzing scientific literature. I went through a couple of lab papers to see other work that inspired this, using the Fiji program, which I learned by watching a YouTube video, and also researching the cytoskeletal filaments or the microtubule binding. Next. So just with continuing with my project, the inhibitor that we used was called SMI-FH2. And at the end of this project, we really have successfully figured out how to determine fluorescence intensity and have begun to analyze the data that I collected from analyzing different groups of images. I was provided the images from my mentor that she got from her lab, the Viscara lab. And yes, okay, next. So here you can see, not so clearly, but you can see some samples from the different groups of images that I analyzed. So there are 4 groups, 4 wells, each with different levels of inhibitor. So in well 1, you can see there's no inhibitor. In well 2, there's 120 micromolar of SMI-FH2, which is the inhibitor we use. In well 3, there's 60, and in well 4, I believe there was 30, or I'm not sure, but 20. Okay, close. And so you can see that with no inhibitor, the fragments, the light, the fluorescence is very cut up. It's not super clear. I mean, well, actually, sorry, I meant to say that with the no inhibitor, it's a little brighter And with more inhibitor in CN120, it's a lot less because you can't see it because it inhibits the microtubule binding and the fluorescence, the emitting light. Next. So this is a chart that I constructed to show after I analyzed all those images. I analyzed a total of 32 images. So in each well, there were 8 images. And I color coded it so you can see well 1 through 4 with the different colors with the mean average fluorescence on the y-axis. And so it just shows really what you would expect is well 1 with no inhibitor. You can see it really has the highest average fluorescence, which makes sense because nothing is stopping that fluorescence from emitting. But what's strange is that you would think well 2 with the most inhibitor would have the lowest levels of mean average fluorescence. But in reality, from what I saw, is that well 3 with only 60, which is lower than 120, actually has lower fluorescence intensity than the well with the higher inhibitor, concentration of inhibitor. So it really just shows that research doesn't always go as planned, and through further analyzation of the images and analysis of the images, and you can see more and perhaps find a different pattern that we weren't expecting, but this is what we found. And up here on the top right, I just showed another data point, just the average of all the images in each well. So it shows again in well 1, it has the most because it's no inhibitor. But again, also well 3 actually has less than well 2, even though you'd expect the opposite. Next. So just beyond this process that I analyzed all these images, I did like a side experiment just to see fluorescence in real life, because, you know, what really is fluorescence? So using alcohol, I really extracted the dye from turmeric powder, spinach leaves, and eggplant. So household items, I found them around the household, and I found this kind of project online where essentially I built it myself. So you can see I made this box and I taped black paper all around so that no light would get in, besides the light source, which I used a flashlight that I cut a hole so that it would fit through, and then another hole for my phone to take a picture of the sample, which is right there. I actually used a Tic Tac box. It worked perfectly. And I put the alcohol that I soaked turmeric powder, spinach leaves, and eggplant in separately. I took that solution and I put it in the Tic Tac box, and I turned on the flashlight and it emitted the fluorescence, the dye color. And so I could just see that because I was provided the images for my experiment just analyzing them. So this was really just beyond that to learn something else, to learn it in real life and something further. Okay, next. So here are the pictures, the Tic Tac boxes. You can see the eggplant, turmeric powder, spinach leaves. And I use an app just on my phone just to see the different levels of color within each sample, each solution. So it just shows, you know, there's fluorescent signs everywhere. Yeah, next. So my magical experience was indeed magical. I really enjoyed learning. I accomplished the goal of learning research skills and lab skills, and the really things that I wouldn't have had the opportunity to learn otherwise, because it's really beyond my schoolwork, and this provided me with that. And I also really enjoyed interacting with a woman in STEM, because, you know, women empowerment is really awesome. And I know that everything I learned here I will take later with me in life. Thank you. Next. Thank you.
Wonderful. Thank you so much, Talya. Do we have any questions either in the classroom or over Zoom?
Did you look at all into reasons why maybe that lower level in level 3 allowed, you know, the lower level inhibitor was not exactly what you expected it would be?
Right. So Dr. God just asked if I looked into why well 3 was really inconsistent with what we expected. And the truth is I did not. I didn't have the time, but I definitely would be interested in pursuing it and perhaps getting another group of images and analyzing it and making the graph again and seeing if it matched up or if there's something different and if a new pattern can be seen or something like that.
Wonderful.